Good morning, students. Today we are getting into the second unit, the first subtopic, observation of climate change, changes in patterns of temperature, precipitation, and sea level rise. Introduction to climate change observations. The first slide. Earth climate system is undergoing significant shift driven by both natural variability and human induced factors. So the climate by nature itself, if there is no human exists, just imagine the climate will still existing because of the sun radiation and the heat will be formed on the surface of the water. So as I know, we have ENSO events like El Nino and La Nino. Because of that, there will be obviously a climate pattern. Okay, but what happens because of the human activity, it enhances. So how to reduce that one? That's what we have been seeing for the in the subject global climate change. So the first point is very clear. There is a significant shift, not only by natural means, but also by means of the human activities. Observation confirm changes in global regional temperature, precipitation trends, and sea level rise. So it is very clearly able to see the not only it affects the regional temperature, it also affects the global temperature and also the global precipitation rainfall trend, as well as there is a sea level rise has been clearly observed by many people. Understanding these changes is essential for environmental planners, policymakers, researchers, and students to anticipate impacts on water resources, agriculture, ecosystems, and human settlements. So, when we try to observe by this type of changes, it able to predict, to plan ourselves accordingly. I mean, to anticipate the impact. So, what will happen on the agriculture sector and how the ecosystem will get affected, so that we could able to mitigate the effect by means of our own action. That's the meaning. Accurate observation data supports evidence-based decision making and enhance the reliability of climate projection. Understanding these changes, okay, so the accurate observation will help us to evidence-based decision making. Okay, because of that, this is happening. So I'm taking a counteract effect. Accurate observation data supports evidence-based decision making and enhance the reliability of the climate projections. Why observation matters? So now it's very clear. They put a question why the observation matters. Observational records provide factual evidence that validate climate models and informs policy. Okay, factual evidence why this is happening. It will give you a clear-cut idea that validate the climate models. Okay, and inform policy. They help distinguish short-term variability from long-term climate trends. So what is short-term variability and long-term variability? The seasonal fluctuation. Okay, so only during summer there are 1 or 2 days it may rains, or during winter rainy season there is no rainfall for during winter there is a rainfall, or during a winter season there is what do you call it, yeah, there is a very warm condition. This is could not able to predict, right? So short term variability only for occurring for a short period, whereas a long term climate trend is need to be considered very keenly. Okay, so the reliable data enables the prediction of impact on hydrology, biodiversity, agriculture, and coastal systems. Without systematic observation, it is difficult to separate natural phenomena from anthropogenic effect. So if you don't keenly observe, it is very difficult to identify whether this is happening because of the natural phenomena or by means of the human made activities. Monitoring temperature, precipitation, and sea level supports mitigation and adaptation strategies globally and regionally. Global surface temperature trend. Global average surface temperature has risen consistently since 1861. So what happens? Okay, after industrialization, is it increasing? Okay, obviously because of the man-made activities after industrialization is quite keep on increasing. But what they say here, even before that, okay, around 1861 itself, the global average surface temperature has risen consistently since 1861. That's what they are stating. Why? Why? Because of that, why they say Act 1861? So try to identify the reason for it. Okay, whatever the statement, okay, which has been given in the book, or even we are just, I'm just telling myself to you. Okay, don't take it as such. As an engineer, you need to understand, okay, whether this statement is correct or not. Okay, that will help you to achieve a long term goal throughout your life. Okay, so we need to say it is an analysis. Okay, so you don't take it as such. Find out the reason why they are saying like this, and what is the evidence for that. Okay, that's what I mean. Okay, mean temperature is calculated from surface air temperature over land and sea surface temperature referred to 1961 to 1990 data. Two periods show sharper rises, that is from 1910 to 1940 and 1980 to 1980 to 1990, reflecting combined natural and human influences. Okay, so 1940 during the first World War, in 1940 after that Second World War. So there is an increase in temperature, right? There is an increase in temperature trend found to be 1910 to 1940 and 1980 to 1990. Rising temperatures have wide-reaching implications for ecosystems, weather streams, and water cycles worldwide. Trends indicate that warming is unevenly distributed across regions. It's not, as I told you, the temperature has been increased from 1.8 degrees Celsius around the globe, but this 1.8 degrees Celsius is not common everywhere. Some places only zero point 0.5 degrees Celsius increase has been found. Some regions it has been found to 3 to 4 degrees Celsius. At an average, it is found to be every year 1.8 degrees Celsius increase in temperature. Is a very alarming thing. That's why most of the countries have been started to reduce their carbon footprint. That means because what are the effect which has been caused by the anthropogenic activities, they want to come and cut down the thing, carbon footprint. Okay, so the regional temperature patterns in India. India shows a warming trend of zero point 0.2 to zero point 0.4 degrees Celsius per 100 years in mean annual temperature. So per annual is only zero point 0.2 zero point 0.4 degrees Celsius increase in temperature for 100 years. Okay, in India, warming is more evident during post-monsoon and winter seasons with minimal change during the monsoon. So it is very clear there is an increase in temperature during the post-monsoon and also the winter seasons, but minimum changes have been found. Maximum temperatures are rising in most regions, but the northwest shows non-significant trends. So in India, that is not all the parts will be have an increase in temperature. Certain parts has doesn't show the non-significant trends. Minimum temperature, that is especially northwest. Minimum temperatures shows here notable cooling in northwest India, that is zero point 0.6 degree per 100 years. Okay, notable cooling in northwest India. So in the previously the statement shows, but the northwest shows non-significant trends, but minimum temperature that they have shown is zero point 0.6 degree, which is found to be a non-significant. Such regional variation influence crop cycle, hydrology, and energy demand. Crop cycle, as I told you, if the climate is changing, okay, the farmers could not able to predict the climatic condition, so they could not know what is the type of crops need to be cultivated in that particular time. Okay, so because the plantation depends on the climatic condition as well as the rainfall, the precipitation. So the hydrology is very important, and also the energy demand. Seasonal regional variation influence the crop cycle, hydrology, and the energy demand. Regional temperature pattern in the Arctic. So at the top of the earth is Arctic and the bottom is Antarctic. So you should know the difference actually where is the Arctic located and what is Antarctic. And also I would like to say in the last class itself what is hemisphere, that is a northern hemisphere and southern hemisphere. So I will have a one question to you, whether India lies in the southern hemisphere or northern hemisphere. Just try to find it out. So usually the earth has been separated into two parts, the equator, above the equator and below the equator. It is the hemisphere has been very close to the equator or below the equator. Okay, just how it has been segregated, north and southern. Okay, with respect to the equator, just go and see yourself. Okay, rather than I try to say. Okay, you will forget it. Show the image, see the image. There are a lot of images are available in Google. Go to the image part and then try to see how where the Arctic Ocean, what is Antarctic Ocean. Okay, that is what do you call it, the Southern Ocean. Okay, where it is located, Arctic and Antarctic, how the hemisphere has been separated, whether it is close to the equator or away from the equator. Okay, so these are the things you're supposed to know, and also try to identify whether India is lying in the southern hemisphere or northern hemisphere. Okay, so this results contradict some general circulation model prediction, which expect greater warming at higher latitudes. Differences highlight the complexity of polar climate system and possible local feedback mechanisms. Warming is an Arctic effect. Permafrost stability, ice cover, and global ocean circulation. Accurate Arctic data is critical due to its global climatic influence. Okay, so please try to find out the region temperature pattern in the Arctic as we did for the we talked about in India. So now we move to the temperature pattern in East Africa. So here you see the temperature has been increased from 3 to 4 degrees Celsius warming. Okay, is projected to experience 3 to 4 degree warming in December to February. Okay, DJF, December, January, February, and 2 to 3 degrees Celsius in June to August. January, June, July, August. Okay, so such warming may intensify the evapotranspiration, evaporation and transpiration. Evaporation, water is getting evaporated from the ocean, and transpiration is the plant take up the carbon dioxide and release of the oxygen. So such warming may intensify evapotranspiration, reduce soil moisture, and alter agricultural productivity. So reduce soil moisture. What is the effect on the soil? So if the soil characteristics has been reduced, if the soil characteristics is mainly used for what is called is one of the parameter that will help you to grow a crops, right? So if the soil moisture reduces, what will happen? Okay, so whether the sustainability, I mean, whether we could be able to use that soil for a particular purpose. Yeah, okay, they even in when they want to construct a high-rise building, they will study the characteristic of the soil. Okay, especially high-rise building or amusement park and things, because there will be a sliding effect takes place if the soil does not have a higher character, good characteristics. Okay, what do you mean? What I mean good characteristics? Just go and see. Okay, what are the characteristics which will talks about the whether the soil is good or not in terms of crops for cross cultivation and also for the construction. Okay, okay, that you need to know. Changes in seasonal temperature will influence rainfall pattern, wildlife migration, and disease vector. The average, even moderate warming can increase the heat stress for human population and livestock. So if even we think of 1 degree Celsius or 2 degrees Celsius, obviously it is heat stress for the human. Every year it has been increased to 1 degree. Just imagine, after some time it become a very hard to be survive here, right? Adaptation measures will be crucial for water management in agriculture and urban areas. So the temperature pattern will affect the agriculture and as well as the urban areas. That's what they mean. Okay, adaptation measures will be crucial, very important. Okay, because of this effect, what is the counter effect need to be done in order to reduce this increase in temperature? Precipitation trend, global perspective. Coming to the precipitation trend, that is a rainfall. Okay, a global precipitation pattern are not uniform. Okay, you don't find a uniform rainfall in all the regions. Some regions will be brought by nature itself. Okay, if you go to Serapunchi in India, you will find every year there is a rainfall will be there. Okay, so throughout the year rainfall will be there. Just go and see how much centimeter of rainfall has been recorded in Serapunchi per year. Just go and find it in the internet. Okay, Sirupinchi is a place where it has been located in northeast of India. Just go and see the geographical location as well as the rainfall pattern in that particular region. Okay, hope you might have studied actually during your school days itself. But if you forget, just go and refer back the things. And the observations show slight overall increases in global average precipitation since the early 20th century. So from 21st century, early 20th century means after 1900s, that's what the 20th century, right? So after the industrialization, they are talking about mainly. So there is a slight overall increase in global average precipitation. So it's good. It looks like good, right? But it's not good. So increase in rainfall also affect the human activities and affect the ecosystem. Okay, that you need to keep in mind. The increase is more prominent in middle and high latitudes of the northern hemisphere. Okay, in the northern hemisphere, it has been found to be very prominent. Okay, tropical regions display complex changes often linked to El Nino southern oscillation events. El Nino that we have already seen in the ENSO events. so I don't touch upon here. Okay, just go and refer back the things. Tropical region display the complex changes. Okay, underline the word complex changes. So what is it by complex changes? That means it's very difficult to identify the pattern. Tropical regions display the complex changes. Okay, complex changes in the sense it is very high. Okay, display complex often linked to El Nino. That means very high things and also very difficult to predict the things. Complex changes. Okay, so the display the complex changes means very high changes. Understanding the precipitation variability is crucial for flood control, agriculture, and freshwater availability worldwide. Seasonal precipitation changes. Seasonal precipitation changes often have greater impact than annual averages. Okay, seasonal is having a greater impact when compared to the annual average. Many regional experience increased rainfall in seasons, in wet seasons, but more intense dry spells during dry seasons. Many regions experience increased rainfall in wet seasons. In wet season, there is increase in rainfall, but more intense dry spells during dry seasons. Such shifts stress water management system, especially in agricultural zones. So, if there is no rainfall during dry seasons, what will happen? More intense dry spells. That means there will be scarcity of water may arise. Okay, such shift stress water management system, especially in agricultural zones. Changes in the timing of monsoon rains influence the crop plantation cycle and yields. So, as I told you, the farmers will see look for a correct time. Okay, they will cultivate. So, during they could not able to predict if there is a shift. Okay, seasonal shift can exacerbate water scarcity in already vulnerable regions, affecting livelihood and food security. Precipitation changes in India. So how the rainfall changes in India? India's monsoon rainfall shows no consistent long-term trend, but significant regional variation exists. So rainfall, no consistent long-term trend, but significant regional variation. Okay, that will exist. Northwestern and northeastern India have seen decreasing trend in seasonal rainfall. This rainfall is getting reduced in the northwestern part of India as well as the northeastern part. Central and southern region often report slight increases but with higher variability. Shift in monsoon onset and withdrawal dates are becoming more common. This changes challenge irrigation planning, reservoir operation, and drought preparedness. So, irrigation planning, reservoir operation. That means every irrigation, the people will look for whether the what is the Kaveri River has been opened for a plant. What is called plantation or cultivation. Okay, during the month of June first week, they will try to open. Hope you would have seen the dam has been opened. Okay, so the reservoir operation, if there is rainfall is full, I mean, water has been fully covered, then only they will try to open. I mean, the dam has been fully full operation condition, then only they will try to open. Full operation condition. What I mean is that it has been filled with full water capacity. East African rainfall pattern. Now, we just will see what will happen to the East African rainfall. Is very close to India, okay, when compared to the US. East Africa experienced erratic rainfall pattern, heavily influenced by ENSO events and the Indian Ocean dipole. So, what is Indian Ocean dipole? Because of the changes in temperature on the surface of the water, the wind pattern arises. That's what we say in El Nino events, right? So the Indian Ocean dipole is a climate pattern characterized by fluctuation in sea surface temperature between the western and eastern tropical Indian Ocean. It is coupled ocean atmosphere phenomena similar to El Nino southern oscillation in the Pacific, but in the Indian Ocean. A positive Indian dipole, okay, meaning to say ozone dipole, Indian Ocean dipole, means cooler waters in the east and warmer waters in the west, while a negative Indian Ocean dipole is the opposite. So it's nothing but a climate pattern characterized by the fluctuation in sea surface temperature between the western and eastern tropical Indian Ocean. It's a weather pattern. Okay, it's getting heated up because of that. What happens? It's a climatic pattern. These changes occurs. Okay, so that's called Indian Ocean dipole. Wet seasons have shown declining rainfall in many areas over the past decades. Short rain are becoming less predictable, affecting the crop harvest. These rainfall changes are linked to food insecurity and reliance on the humanitarian aid. Okay, so declining rainfall, wet seasons have shown declining rainfall. So you just see in the Eastern Africa how this has been affected. The people will be sometimes suffering with drought. That means they don't. There is no water actually found. Okay, adaptation strategies include drought tolerant crops. Okay, so even if there is no rainfall, there is some crops that will cultivated. Okay, adaptation strategies include drought tolerant crops and improve the rainwater harvesting. Arctic precipitation changes. Arctic is a part of, which is located at the top of the uh, planet. The top part of the region is called Arctic. Arctic region shows an increase in annual precipitation, largely falling as rain instead of snow. Winter precipitation is rising more rapidly than summer precipitation. That means during winter there is more actually the snowfall. Okay, show an increase in annual precipitation, largely falling as rain instead of snow. Winter precipitation is rising more rapidly than summer precipitation. This shift accelerates ice sheet melting and reduce the snow cover duration. Very, very important. Okay, instead of snow falling, largely falling as rain. So what happens? Melting takes place. The impact extends to river runoff, which affect the freshwater balance in the Arctic Ocean. Increased rainfall on ice surface enhances the meltwater penetration and glacier retreat. Very, very important point. Sea level rise. Global trends. Global means sea level. Global mean sea level has risen by 15 to 20 centimeter. So as I told you, because of the global gas emission, what will happen? Low-lying countries will be affected because of increase in the sea level. So the global mean sea level, okay, has risen by 15 to 20 centimeter over the 20th century. Now we are in the 21st century. Last year, what happened? 20 centimeter increase in the sea level. The rate of rise has accelerated since 1990s, currently at about 3.3 millimeter per year. Per year, 3.3 millimeter, imagine. Okay, it's a very alarming. Causes include thermal expansion of seawater and melting of glaciers and ice sheet. Thermal expansion of seawater. So because of that, the wind pattern may change. Okay, melting of glaciers and ice sheet. Sea level rise threatens low-lying coastal areas. Underlying the word low-lying coastal areas. Threaten the low-lying coastal areas. Small islands and deltaic regions. Impacts include coastal erosion, salinization of fresh water. The fresh water become saline. Okay, that means become salt. Salination of fresh water and displacement of population. Thermal expansion of seawater. As seawater warms, it expands, a process called thermospheric sea level rise. Thermal expansion contributed to about 50% of the observed rise in the 20th century. So, in seawater thermal expansion, okay, 50% of the observed rise in the 20th century, thermal expansion contribute. Okay, please understand. Warming of the deeper ocean layers adds to long-term sea level rise. This effect is irreversible on human timescale due to slow cooling of ocean waters. Limiting ocean heat take-up is crucial for controlling the future sea level trends. Okay, so we should be very careful on this part as well. Thermal expansion of seawater. Okay, melting glaciers and ice sheet. Melting of glaciers in Greenland, Antarctica, and mountain regions contribute significantly to sea level rise. It should not melt actually. So for that, the snow is supposed to fall on the Arctic and Antarctic. Otherwise, what will happen if rain falls? Obviously, that will reduce the melt the ice which has been present in the Arctic and Antarctic. And Greenland ice sheet melt alone account for zero point 0.8 millimeter per year. Almost Greenland, near to the Greenland ice sheet melt almost, it increase in level of zero point 0.8 millimeter per year of global sea level rise. Antarctica contribution is increasing due to ice shelf collapse and basal melting. Glacial retreat also disturbs the freshwater supply for millions worldwide. This process is intensified by positive feedback loops in the climate system. Regional variation in sea level rise. Sea level rise is not uniform due to ocean current, winds, and gravitational effect. Sea level rise is not uniform due to ocean current, winds, and gravitational effect. Some regions experience rates twice the global average, while others see the minimal change. The regional variation in sea level is not common throughout the globe, is not evenly distributed. That's what they mean, as the temperature is not evenly increasing or throughout the globe, but at an average it has been increased. So here also at an average the sea level has been increased, but it's not even for all the regions. That's what they mean. Land subsidence can exacerbate apparent sea level rise in deltaic regions. Local monitoring is essential for tailoring adaptation measures. Regional projections help prioritize infrastructure investments and coastal defense. Impacts on coastal ecosystems. Rising sea level threaten mangroves, coral reefs, and salt marshes. So, how the coastal system has been affected, the marine life, the coral reef, which has been present underneath the sea. So, if the scuba diving people, when they shoot the videos, you might have seen the coral reefs, how it looks like. Go and see the coral reefs. Okay, rising sea level threaten the mangroves and the coral reefs and salt marshes. Saltwater intrusion disturb the freshwater habitats and agriculture. The saltwater intrusion, that means what happens if you are living in a coastal region, some part of the land, the intrusion takes place, infiltration takes place from the seaside. So you don't get a fresh water, you will get a salt water. Okay, saltwater intrusion disturbs the freshwater habitat as well as the agriculture. Coastal erosion alters the shoreline stability, reducing the natural barriers to storms. Loss of intertidal zones impacts fish breeding grounds and biodiversity. Conservation strategies include restoration of coastal vegetation and integrated management. Excuse me. Impacts on human settlements. Coastal cities face increased flooding risk from storm surges and high tides. Infrastructure such as ports, roads, and sewage system is vulnerable to inundation. Rising seas can force relocation of communities, creating climate refugees. Okay, so coming to here, rising sea level. For example, I want to vacate, make them to vacate the people who are living in the low lying areas. Okay, because of this increase in sea level. Okay, so to safeguard them. Okay, relocation of communities need to be taken place. So they creating a climate refugees. Climate refugees means they lose their houses. Am I correct? So, for example, in cyclone or during a flooding season in Chennai, especially I just give an example in Chennai, what will happen? The people have been migrated to go and make them to live in a safe location. Example, marriage hall, or even go they just put in temple and things like that for this to for them to have a safeguard, because the houses may not be in a constructed in a good manner. Okay, they will scared to live in that particular houses because of the heavy rainfall. There may be a collapse or a slide if you go in a what you call sliding regions. I mean high altitude region, there will be sliding may takes place. Okay, because of that, the people will be relocated in a safer region. So there, similarly, the people who are living in the low-lying regions need to be relocated to a safer climate. They become a refugee because they lose their houses and everything what they have. Okay, housing and insurance costs will rise in high-risk areas. Urban planning must integrate sea level projection into development policies. Interaction of temperature and precipitation changes. Rising temperatures intensify evaporation rate, affecting rainfall patterns. So evaporation rate is increasing, obviously the rainfall will be more. But a normal rainfall and if increase in rainfall, okay, there is a change. So that means that's what they say is affecting the rainfall pattern. Warmer air holds more moisture, leading to more intense rainfall events. Okay, so warmer air holds more moisture and leading to more intense rainfall events. So what happened? The water, warmer air holds more moisture. Please keep in mind warmer air. So if air is cool, it does not. What is the tribal temperature and well temperature of the dry air and wet air? Okay, just see, go and see the and refresh back the things what you have stated in master. Okay, warmer air holds more moisture, leading to more intense rainfall events. Conversely, high evaporation can worsen the drought condition in arid zones. Okay, this interaction influences water stability and agricultural productivity. Climate models most account for this coupled effect for accurate forecasting. Extreme weather events. Climate change increase the frequency and intensity of extreme events. Example include heat waves, floods, droughts, and cyclones. Okay, because of the weather pattern, what are the things it may happen? Heat waves will come. Okay, the hot stroke may comes actually if there is a heat waves for the people who are old, and flooding. Okay, flooding may comes. Drought region drought takes place. Okay, cyclone may occurs. Extreme rainfall events are likely linked to urban flooding and infrastructure damage. Okay, extreme rainfall. As I told you, if there is a extreme rainfall condition, the urban flooding, okay, and infrastructure damage may take place. Heat waves impact human health, energy demand, and crop yields. Okay, mitigation and preparedness strategies are vital for disaster risk reduction. Coming to the case study, okay, 2015 Indian heat wave. The 2015 Indian heat wave killed around 2,000 people in Andhra Pradesh and Telangana. Just see, because of the heat wave, it was very common. Even I just advised my father don't go during the summer season from 11 to 4 because of this reason. Okay, because they once they become old, is very susceptible to heart stroke. Okay, I mean heart stroke in the sense that what I mean is the heat stroke. Okay, not heart stroke. Sorry, heat stroke. Temperature exceeding 47 degrees Celsius is causing widespread heat stress. Uh, Water storages worsened due to delayed monsoon onset. This even illustrates the compound effect of temperature extremes and precipitation deficits. Public awareness, heat shelters, and early warnings are crucial for reducing casualties. Observation tools, temperature. Surface temperature is measured using thermometers, automated weather station, and satellites. Okay, so surface temperature is measured by the thermometer, automated weather stations, and as well as the satellite. Satellite sensors provide global coverage for sea surface temperature. How to measure the temperature by means of satellite or even the tools which are available. Okay, even we have a radar station every 360 kilometer in the southern part of region like Chennai. We have a radar station. The next station will be in Visakhapatnam. On the other side, we have a radar station in Karaikal in my hometown. Okay, so what they do actually, they will try to measure the temperature, weather pattern, wind pattern, and everything, and so on and so forth. Okay, weather meteorology only, including the temperature need to be maintained, need to be will be measured. Okay, so urban heat islands require localized measurement networks. Long-term data is stored in climate achievers for analysis. Modern system allow real-time monitoring and public data accessibility. Okay, rain gauges and weather radars are primarily tools for precipitation measurement. Okay, weather radars will be there. So how much is the rainfall? Satellite-based sensors like TRMM and GPM track global rainfall. Is a sensors like is a sensors. Just go and see the what is the thing because a lot of sensors are available to predict the satellite-based sensors like this one will help you to track the global rainfall. Radar provides spatial coverage for storm monitoring. Gauge networks for essential for ground truthing satellite data. Combining multiple sources improves accuracy and reliability of the precipitation data. So you don't observe the one tool and then try to find it out. You just use different tools and then try to see the accuracy, how it improve the accuracy. Okay, so that's what they mean. Observation tools, sea level, tide gauges measure long-term changes in coastal sea level. Satellite altimeters like Topax, Poseidon, and Jason series provide global sea level maps. GPS sensors monitor land subsidence and uplift near coast. Buoy systems helps measure wave height and ocean current. So sea level, some of the tools have been used in order to see the rise in tidal tides, okay, and height of the ocean. Buoy system helps measure the wave height as well as the ocean current, okay, and also it has been as land subsidence and uplift near coast GPS sensors. These tools provide the include for coastal risk assessment models. Okay, because of the tide increase, what will happen? The ocean current is heavy. What will happen? How the wind patterns? Tide gauges measure long-term changes in the coastal sea levels. Data quality and reliability. Climate data must be accurate, consistent, and comparable over time. Calibration of instruments ensures measurement precision. Data gaps are filled using statistical interpolation methods. Quality control removes erroneous readings from datasets. International collaboration ensures standardized measurement protocols. Role of remote sensing. Remote sensing allows large scale continuous monitoring of climate variables. Satellites detect changes in land surface temperature, vegetation cover, and snow extent. Obviously, because of the satellite is very helpful for many things. Okay, it also measures the temperature, vegetation cover, and as well as the snow extent. Ozone color sensors track chlorophyll levels. Um, indicating biological productivity. Remote sensing helps in early warning system for extreme events. Okay, data integration with ground station enhances the forecast accuracy. Okay, this all will help you why we need to do all this actually because of the for our protection. Climate models and observation. Observation validate climate model outputs, ensuring realistic projections. Models use observed data for initialization and calibration. Discrepancies highlight areas where models need improvement. Reliable observations improve regional climate simulations. This synergy is critical for adaptation, planning, and policy formulation. What are the challenges in climate observation? Sparse observation network in remote regions limit data coverage. Okay, political and logistical barriers hinder data sharing across countries. Okay, instrument errors and environmental interference affect measurement accuracy. Long-term funding is essential for maintaining the observation systems. Rapid technological changes require continuous training for operators. Challenges in climate observation. Once you know the climate observation only, once it has been confirmed, then only we can go on take a counteracting effect. Adaptation strategies, coastal defenses like sea walls and mangrove restoration reduce sea level impact. Okay, mangrove restoration, mangrove forest, you might have seen actually that it has been proved that the tidal waves and the waves which is coming can be softened. That means it can be reduced. Okay, predominantly because after the corona, what do you call tsunami, most people have been started to plant the mangrove forest, okay, near to the coastal areas. Some they just try to construct a wall. That also happens. Okay, but it's a poor understanding. By walls, you could not able to stop the thing. But however, if it is a low-lying sea is at the low level and what you call the sea is at the top and the regions are which are lower that will lift the things. Okay, that's all. But it will not stop the flood of tsunami which is taking place. Okay, that means the wall which has been constructed. But mangrove forest has been scientifically proven. It will try to reduce the effect of the tidal waves. Okay, when it comes from due to tsunami or even by nature, the waves which is coming by nature. Okay, the water saving irrigation and rainwater harvesting address the precipitation variability, heat resistant crops and improved storage ensure food security, urban green spaces mitigate heat island effects, community awareness program improve climate resilience. Okay, so these are the adaptation strategies. They mean mitigation strategies. That means trying to reduce the things. Reducing greenhouse gas emission is a key to slowing the climate change. So what you need to do, where you need to cut adaptation means after it has been happened, how to protect ourselves. Mitigation means try to reduce from the source itself so that it will not happen again. Reducing the greenhouse gas emission is a key factor and key things that need to be done in order to reduce the climate change. Renewable energy adaptation cuts carbon intensity, so don't use the carbon sources, okay, especially the coal and fossil fuels. That will obviously will leads to a increase in carbon footprint. So go for a solar wind or solar energy or wind energy or tidal energy or ozonic energy and things like that in order to go for a electricity production so that the renewable energy source has been adapted to cut down the carbon intensity. Energy efficiency in transport and industry lowers fossil fuel demand. Okay, energy efficiency in transport, that means a good proper of a uh, energy efficiency in transport and industry lowers the fossil fuel demand. That means optimize the process or optimize the things and in the transportation like automobile use the good engines. Okay, so that the carbon dioxide exhaust will be less. Okay, similarly they are what they are trying to say is that that will reduce the fossil fuel demand. Okay, so carbon sequestration, energy efficiency in transport, even electric vehicle, they just think of the electric vehicle. Okay, excuse me. Carbon sequestration through afforestation and solid management helps offset emissions. International cooperation supports global emission reduction targets. In conclusion, what I would like to say is that we have seen the observation of the climate pattern, what is how to adapt, adaptation strategies, mitigation strategies. Okay, I will just would conclude this today's section by five important points. Observation confirms significant climate changes in temperature, precipitation and sea levels. So it's very clear the climatic changes occurs because of the temperature, rainfall as well as the increase in sea level. Regional variation underscore the need for localized adaptation plans. Okay, there is two things: regional variation as well as the global variation. Both is not common. Okay, that is one thing we have also seen in temperature as well as in rainfall. Regional variations underscore the need for localized adaptation plan. Robust observation networks improve prediction accuracy and policy relevance. So we need a corresponding tools in order to measure this increase in rainfall or increase in sea level satellite image, and that will help you to find the prediction of what is the changes which is happening. Okay, and that will help you to create a loss policy relevance. Climate change impacts are interconnected, recurring integrated response. Okay, so one region it has been happening, so I want to take a action plan only on that particular region. That will not work out because it's not evenly distributed. Okay, and we have seen different regions have different patterns, rain patterns or temperature patterns as well as I mean patterns in the sense not natural means it has been changes in patterns. Okay, so continued monitoring and combined with mitigation and adaptation effect. Mitigation means trying to reduce from the source, okay, or trying to reduce it. Adaptation means it is happening, but how to protect ourselves from the changes. Okay, so with this note, I would like to conclude today's section. Hope you will see in next class with the second subtopic of Unit 2. Thank you.